Hello, and here's our first unit, probability unit, and we're going to get started on this. When we do probability, we know probability is the likelihood of something going to happen that we want to happen. And we have to know the number of successful outcomes and compare that to the number of total outcomes. So before we can get to the probability part, we got to figure out how do you calculate all of the number of possible outcomes. So the first couple of lessons here are just on figuring out the number of lessons. Number of outcomes. So let's get started here with this one. Okay, so let's start with real something here, real easy. And we have Shaminda signing up for her classes. Most of her classes are required, but she has 2 electives. For her art classes, she can either choose between art, band, chorus, or drama. And for her language classes, she can either choose French, German, or Spanish. Those are her 2 electives. Well, she decides she's going to organize her data. So what she's going to do is she's going to let A, B, C, and D represent the art, band, chorus, and drama, and the F, G, and S represents French and German and Spanish. So we need to complete a diagram that's below here. Well, what you would do first is you'd go ahead and put in your A, B, C, and D. Okay, those are your 4 options. Now from that, in each one of these, you can have your math a G or an S. In every one of these. There we go. Kind of clean that out a little bit. Okay, so there we see that we have. So if she chooses art, she can still choose French, German, or Spanish. Yeah, Spanish. Okay, so that means these are all her possible outcomes. She could have art in French, or art in German, or art in Spanish, all the way along the lines. So this is a number of possible outcomes that she can come up with using what we call a table method or a tree method. You actually have your first options, your second options are listed there, and then you have your possible outcomes. So now when we see this, we can figure out that she has a total of 12 different possible outcomes from this method. Now, what's the advantage of using this tree method is you can see what each outcome is. Say we had another class that we needed to put in there that she could take. She could either take algebra or geometry, or both, but we won't go there. Algebra or geometry. We could add that in here as well, and then we could look at how many of the, all the way through. Now, is there a way to do this without having to make this tree diagram? That's the big thing we want to find out. So is there a way that we can do this without finding the tree diagram? What happens is we can use what's called the fundamental counting principle. If event M can occur in M ways, and then is followed by event N that can occur in N ways, then the event M followed by the event N can occur in N times N way. So what does that mean for us? That means for us, we have 4 elective classes for arts, and we have 3 elective classes for language, which means we have 4 times 3 ways. We have 12 ways of doing this. Now, the advantage of this is we know how many outcomes we can have. The advantage of the tree is that we can see what those outcomes are. We can see that we have 12 outcomes and see what they are. So if I need to see what they are, I want to do a tree. If I just need to know the total outcomes, then the counting principle will work. Now, the next part here is we have to decide. In her case, did it matter if she picked art and any one of the languages? It didn't matter. So we call that either an independent or a dependent event. We have to be able to identify which is which. Are they independent or are they dependent? So what's the difference between these? Well, let's look first. An independent event happens if the outcome of one event does not affect the outcome of another event, or vice versa. So if she picks chorus, it doesn't matter which language she picks. If she picked French, it doesn't matter what her other class was either. They're independent of each other. The other category there is dependent. Now, dependent would mean that the outcome of one event does affect the outcome of the second event. However, the fundamental counting principle can still apply. You just have to make sure you remove it. Here's an example. Let's say that if she chooses drama, that's a 2-period class. If she doesn't choose drama, then art or band or chorus, she has a 2nd period free. Well, if she chose drama, then she couldn't get a language. So that makes it a dependent event. Something along those lines. So here we have a couple examples. We have a marble is drawn out of a jar and is not replaced. And a second marble is drawn. Now, is this an independent or a dependent event? Well, it comes down to this little statement right here, namely that it is not replaced. So if I take a marble out of that bag and I don't replace it, it's dependent, because now I no longer have that marble to be able to take it out with. Okay, so now a marble is drawn out of a jar and is put back in, the jar is shaken, and a second marble is drawn. Well, now when I go back into the second time, all 13 marbles are in there again. This is an example of an independent event. Okay, so there's the idea. So let's take a look here. Let's say I had 4 coins will be stacked together, dropped onto the floor, and then check to see how many heads are facing up. Is this independent or dependent events? Well, how do we determine that? Because we just dropped 1 coins. What we need to look at is each of those coins is an event by itself. So does the result of 1 coin affect what the result of the next coin is going to be? Well, since we're dropping them on the floor, no, it doesn't matter. It's not like we're going to drop it on the floor, and if it's a heads, we're going to do something with it. We're just going to drop all 4 of them and then count. So in this case, we would consider them independent events, because each coin itself has its own outcome. Now, how many total outcomes are possible? Well, I've got 4 coins. So if I think about 4 different outcomes, each outcome has how many ways that it can happen? Well, the first one has, let me switch this back to a pen. There we go. The first one has 2 outcomes. The second one has 2 outcomes. The third one has 2 outcomes. And the fourth one has 2 outcomes. So we have a total of 16 possible outcomes. Now, how many of these outcomes have exactly 2 heads facing up? Well, now, that's interesting because I know there's 16 of them. Does that mean 8 of them have to have 2 heads up? Or does that mean only 4 of them? Because there's 4 coins? So here's where making the tree would be very, very useful to us. So let's go ahead and make a tree here. And I'm going to make this tree run left to right instead of up and down. So I have 2 options. I have a head or a tail option. That's what's going to happen. Now from this head or tail option, I have a head or a tail option for the first coin. So now I'm going to clone that and put it down here. I'm going to make that an infinite cloner, so this will work much faster. Okay, so now when I look at this, I better write this down here. This is the first coin. This is the second coin. This is the third coin. Now, what you notice here is I'm running out of room pretty quickly. So I need to make a couple more of these on my own here, maybe something a little smaller. There we go, heads, tails, heads, tails, heads, tails, heads, tails, and the last one, heads, tails. So I got 1, 2, 3, 4, 5, 6, 7, 8 outcomes right there. 9, 10, 11, 12, 13, 14, 15, 16. I got 16 total outcomes. So let's look at this very first outcome. It's got 4 heads. I'll make this a little faster for me too. We're going to make this independent cloners and then independent cloner. There we go. Now the next one had 3 heads and only 1 tail. And now I would just continue all the way down this list until I got to the bottom. So let's see what that would look like. I had to list all 16 as 2 different columns because I didn't have enough room to get them all in there. But now that I have all 16 columns, I can go through and identify when I have a particular situation. I want to have exactly 2 heads. So every time I see 2 H's only in a column, I'm going to highlight that. So what I see here is I have 6 times that I have exactly 2 heads. So the answer to our problem here is 6 times. So the next question that would be coming down the line would be, if I had 4 coins and I squeezed them and I dropped them on the floor, and what's the probability that there would be, what would be the probability that there would be exactly 2 heads facing up? Well, 6 out of the 16 possible outcomes is our probability, because 6 times I had exactly 2 heads up, and 16 was my total outcomes. That's what we're looking at, but we have to be able to figure out those counts first. Okay, so now that's the first part of our lesson. Just figuring out if they're independent or dependent events and calculating the number of possible outcomes using the basic counting principle or the fundamental counting principle. Make sure you watch the second part of this.